Good morning everyone. Today we are going to discuss about counters. So what are counters? Counters are basically the digital electronic circuits which are used to count the number of times an event has occurred with respect to the clock. Basically there are two types of counters, that is synchronous counters and asynchronous counters. In synchronous counters, all the flip-flops which are used to realize the counter are fed with a similar clock. Same clock. That means all the flip-flops are in sync with the clock. Coming to the asynchronous counters, the output of the first flip-flop acts as the clock for the next flip-flop and so on. And the initial flip-flop is fed with the actual clock. So let us now restrict our discussion to asynchronous counters and see how a simple ripple-up asynchronous counter works. So an ripple-up counter, basically I am using a 3-bit ripple-up counter where it counts from 0 to 7 and comes back to 0 on the next realization of the clock. So let us quickly write the truth table, that is 000, 001, 010, 011, 100, 101, 10 and 111. So here if you observe, this is a 3-bit counter and the output is starting at 0 and you get 7 and comes back to 0 after 7. So as it is a 3-bit counter, I'm going to use a 3 JK flip-flop circuits in order to realize the asynchronous counters, and you could see the circuit diagram over here where there are 3 JK flip-flops, and as I said, for the asynchronous counter, the output of first flip-flop acts as the clock for the next flip-flop and so on over here, and the initial clock is fed to the first flip-flop. And we are going to use the important property of JK flip-flop, that is toggle property, where if the both the inputs of JK are 1, then the previous output will be toggled. That means if the previous output is 0, the output will be 1, and if the previous state output is 1, the current state output will be 0. So if you could see over here, we are going to draw the clock. So this is the clock diagram which I am drawing, and then here I would say I would use a negative edge triggering of the clock, because in order to realize the circuit starting from 000, now for every negative edge of the clock, the output will be toggled. That means if you could see over here, the output is the input is 1 1. So if the previous output is 0, the output will be toggled to 1 in this case. So here the initial input output will be 0, that is for A, and at the negative edge triggering, the output will be toggled. That means it becomes 1 and it goes till the next negative edge, and it becomes 0 at the next negative edge, and it goes on. So basically we can observe that the frequency of A is half the frequency of clock. So this serves as the clock for the next flip-flop. So that means the frequency of B will be half the frequency of A. So here the output will be 0. So whenever there is a negative edge triggering, so there is a positive edge. So this is a negative edge, this is a positive edge, this is a negative edge. So this is a positive edge, so there is no change, it continues to 0, and as there is a negative edge over here, the output of B becomes 1, and it continues till the next negative edge, and it becomes 0 at the next negative edge, and so on. That means the frequency is being halved. In the similar manner, it is understandable that as the output of second JK flip-flop B is served as a clock for the third JK flip-flop, the frequency of C is half. There is a positive edge, so there is no triggering. There is a negative edge, so there will be a triggering, and it becomes 1, so on and so forth. So if you could see, the frequency is being halved at every output. So that is the specialty of the counter over here, and the JK flip-flops magic is being played, and we will try to relate the output over here to the truth table here. Okay, so if you can observe here, for every, if you see that for every clock event there is a transition. For every clock event, A is very sensitive and it is toggled for every clock cycle. So we can say that A is the LSB over here. Coming to B, it is quite obvious that the frequency of B is half the frequency of A, so this will be our middle bit, and the frequency of C is half the frequency of B. That means for every 4 clock cycles, I mean for every for every one change in B, okay, I mean for every 4 clock cycles C is getting changed, so frequency, this is C. So that's it. We have realized the simple asynchronous counter using 3 JK flip-flops and using the most important toggling property of JK flip-flops. I hope it is clear, and thanks for watching the video.